So this recording is about scientific notation. A number in scientific notation is written as the product, which of course means multiply, the product of a number between 1 and 10. That 1 and 10 is very important. And a power of 10. For example, 9.2 is between 1 and 10, and it's written as being multiplied by a power of 10. This in this case is 10 to the 6th power. 8.752 is also between 1 and 10, and we've multiplied it by a power of 10 as well. These two are what we call non-examples, means they're not examples, because this number is not between 1 and 10, and this number is not between 1 and 10. Even though it's multiplied by a power of 10, these numbers are not between 1 and 10. So standard form is how you were taught to write numbers. This is also referred to as decimal form sometimes. So these are examples of standard form. Positive exponents, the standard form of the number is greater than 1. So for example, here's 9.2 times 10 to the 6th. That means 6 zeros. So we're going to move it 1, 2, 3, 4, 5, 6 times to get this number. Negative exponents is the standard form of the number is less than 1. In other words, a decimal. So this -5 just tells us which direction we're going. We're still going to move 5 times. So I need to make this number smaller because that exponent is negative. So I'm going to move it 1, 2, 3, 4, 5 times, which is why you see all these zeros over here. And I actually drew one too many, but you get the idea. So let's try a few more examples. So we're going to rewrite these in standard form. Remember, standard form means as a number with no multiplying of power of 10. So 1, 2, 3, 4, 5. I'm going to have to add 3 zeros. And it's positive. That's why I moved to the right, is because I wanted to make the number bigger. This one's negative, so I'm going to move to the left to make the number smaller. And I'm going to move once and twice. So I only have to add 1 0 there. 10 to the 1, I'm only moving once. And I'm moving to the right because I want to make it bigger. 10 to the 4, 1, 2, 3, and 4. Negative, moving to the left. 1, 2, 3. So it's going to be 0.003589. Now, this is a special case. 10 to the 0 power equals 1. So what is any number times 1? Just itself. -5, I'm moving 1, 2, 3, 4, 5. So that's going to be 0.123410056. Woo. 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. So I have to add a 0. So at this point, hopefully you're seeing the reason that we use scientific notation. These numbers are either very large or very, very small. And it would take a really long time for us to write everything out. So we have this scientific notation to make it a little bit shorter. Now we're going to go the opposite direction and rewrite in scientific notation. So remember that my front number has to be between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 7.96, ditch all the zeros, times 10 to the 9th power. Now I made it positive because this was a really big number that I was making smaller, so it was positive. This is a really small number that I'm going to make bigger, so this exponent should be negative. 1, 2, 3, and I stop there because remember that number has to be between 1 and 10. This number is not between 1 and 10, so I'm going to move it over once And my new number is 4.5668. That's times 10 to the first power. 1, 2, 9.98653 times 10, and I moved it twice. 1, 2, 3, 4, 5, 6. This is going to be 5.6388 times 10, and I moved it 2, 3, 4, 5, 6. Lost count there. 6 times, but it's negative because I'm making that small number bigger. All right, so over here we've got 6.3 times 10. 1, 2, 3, 4, 5, 6, 7. 1, 2. And this one's going to be negative. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And 1. So that's all we got for our scientific notation notes today. Go ahead and work on your assignment. They're in page 5 and 6 of your booklet.